All right, everyone. So we'll start the session, and anybody else who joins in will join in later. But everyone who's here, let's get started. So, good morning, good afternoon, and good evening, everyone, wherever you are joining us from. And welcome to this webinar, Career in Data Science and Analytics. We are excited to have you on board on this journey of learning. You can use the chat box to introduce yourself. Where are you joining in us from? What would you be your desired outcome at the end of this session? And anything that you would like to share with us and the other attendees about yourself. So use this chat box to interact, and let's make it as much as possible interactive. So this webinar is first in my Career Pathway Initiative series because journey of learning must continue. Before we get into the actual session, I have a couple of questions to ask, and you can type your answer in the chat box. The first question: in order for all of us to be fully present in this moment and get the best out of this webinar, can I ask you, on a scale of 1 to 10, how focused are you right now? How focused are you right now on a scale of 1 to 10? Let's see. Seven. Anybody else would like to share how focused are you right now on a scale of 1 to 10? Eight. 7, that's good. That's good going. Okay, so let me ask you one more question. And I'll tell you why I ask you this question. I want you to think of 3 people who helped you to be where you are today in life. Think of 3 people who helped you to be where you are today in life. Think about it. If you would like to share with us, well, and if you want to just keep it to yourself, I want you to think about 3 people. I'll give you a few seconds to think about it. 3 people who helped you to be where you are today in life. Dr. Daniel says, mom, dad, and my supervising professor. That's good. Okay, so if you thought about it, why did I ask you this question? You know, when we have this sense of gratefulness, sense of gratitude, and we are thankful to what we have, and our brain opens up to receive new ideas. That's the whole idea of asking this question. So as we get into this webinar, we are focused. Our brain is open up to receive new ideas. So we are ready to go ahead and with the session. So before I introduce our speaker, let me share with you quickly the agenda for the meeting, so you know where we are and where we are heading. Okay, so let me quickly share my screen. So here we are on opening and introduction. All timings are based on GST, that's Gulf Standard Time. And then we will get between 2:15 and 3 p.m. We will get into our actual session, Career in Data Science and Analytics. Then we will have about 15 minutes, depending on how the session goes, on Q&A, and then you can ask questions at the end, or you can even ask questions during the session as we progress. So I'm sure our speaker would be more than happy to. Let me help join a few new people. Okay. So whenever you have a question, just raise your hand or unmute yourself and ask a question, and our speaker, Dr. Daniel Hopman, will be more than happy to answer those questions. Now, so before we get in, a little bit about our speaker. So Daniel Hopman has a PhD in mathematics obtained from Vrije University in Amsterdam. He holds a bachelor and master's degree in business analytics. His research has always been focused on algorithms that can be applied in practice. His main interests lie in dynamic programming and Markov chain modeling. Daniel joined Emirates Airline in 2014, where he quickly rose through the ranks and was part of the digital transformation team stationed in the Mathematical Institute at Oxford University, United Kingdom. In 2018, he joined Majid Al Houtham, where he currently is responsible for analytics and data science for 3 business units. So, ladies and gentlemen, please help me welcome Dr. Daniel Hopman. Dr. Hopman, the floor is yours, audience is yours, and audience, everybody who is in, just please, let's try to make it as much as possible interactive and ask our, very able speaker questions as we progress. So, Dr. Hopman, over to you. Our floor is yours.
Thank you, Abdul. I'm going to start the session with probably the 2 most overused questions in 2020 and 2021. Can everyone see my screen and am I audible?
Yes, we can hear you very clearly, and we can see your screen as well. Thank you.
Thank you. Before I get started, thank you, Abdul, for giving me the opportunity to speak today. Teaching is something that's very close to my heart. I worked together with Abdul 3 years in math, and I'm sure he can attest to the same. And I really want to walk away today with some learnings. So Abdul already mentioned it, but if there's anything unclear, please raise your hand. I really want you to get away with some learnings today, as I mentioned. So, just a brief agenda of today. I want to answer a few questions, and of course, I'm going to talk about data science and analytics, and whether it's for you and how you can get there, how can you learn. But I want to do it a little bit different than most presentations. Most presentations are fairly static in the sense that they start with analytics, then they explain what analytics is, then they move to data science, and it's a very dry kind of content. And I'm really trying to get the same message across, but in a different way. So as an introduction, I do need to give a brief introduction on the different levels of analytics. Some of us may be familiar with those, some are not. Then I go into data science. I talk a little bit about a key principle in data science, in mathematics, in programming, which I think is very powerful and shows the power of data science. And then we're going to finish with 20 learnings of data science in practice, right? So that's what I meant when I said earlier. I really want to focus on things that you can take away from this presentation, and not just go over the standard definitions of analytics and data science, because again, let's be honest, you can look those up yourself on Wikipedia or anywhere else. And we're going to finish with data visualization, which is an aspect of analytics, which is also very interesting to me, and perhaps one of the most important ones, actually. So again, high-level agenda, we're going to start with analytics. We're going to dive into data science, really focus on learnings in practice, and then we're going to end with data visualization. So when speaking about different levels of analytics, the question really is, where does data science fit in, and on what kind of level in organizations as well does data science fit in? So we have all seen a picture like this before, right? So we have prescriptive analytics, predictive, diagnostic, and descriptive, right? So we start from the bottom. What happened, right? So you get your financial results of the past year, and you do some very simple calculations. For example, what is the year-on-year growth? How much did we sell to a certain country or nationality? What kind of products did we sell, and so forth, right? So this is an example of descriptive analytics. When you move a step up, we end in diagnostic analytics, right? And we're trying to understand why did that happen, right? So if I can follow the example that I mentioned earlier, let's say we sold 100 units more than we did last year. Then with this level of analytics, you start to study, okay, how could that possibly, what are some possible ways for that to have happened? So for example, maybe there's a GDP growth in a certain market. Maybe there is a different nationality breakdown. Maybe we just offer different products this year, right? So that's a step up where you do simple diagnostics. Another step up from there is predictive analytics. And what predictive analytics is basically a fancy word for saying forecasting, right? So I'm sure every one of us have worked with forecasting one way or the other, whether that's in finance or whether it's in marketing or basically any part of the business. And we're trying to predict what will happen, right? So based on the fact that we sold 100 units or 100 products more this year, what do we expect that to happen then next year, right? So another step up, what will happen? And then finally, prescriptive analytics, which is considered the holy grail of data science, is what is then the best course of action, right? So suppose that, we started with what happened, right? So we said, okay, we sold 100 units. Then we said, why did that happen? Well, that's because, we had a different nationality breakdown. Then a step up, predictive, says, what will happen? So for example, do we expect that same nationality breakdown next year, or do we expect that same product to sell next year? And then given those three things, what should we then do, right? So suppose that we expect that same nationality breakdown to continue. Perhaps the best course of action is to keep the same pricing policies. Or if you're purchasing some items somewhere, what will happen? There's a global crisis when it comes to shipping. Using prescriptive analytics, what do we then do is we determine what the best course of action is, right? So for example, do we source product locally in the shipping example? Or do we order further ahead, right? So these are just some of the examples. Now, one of the questions that I wanted to ask you, when you look at these levels of analytics, right? So when you look at these different levels of analytics, can be in terms of roles, can be at different parts of the organization. My question to you, my question to the audience is, where do you think data science fits in each of those levels? I cannot see the chat box, so Abdul, if you don't mind to monitor that.
Yeah, of course. If we get the question, I'll definitely let you know.
So let me just maybe ask the same question again. So given those different levels of analytics, my question to you is, where do you think data science comes in? So at what level of analytics? And again, there's no right or wrong. I'm just curious what's on your mind.
Daniel, I guess for me, it would be all 4 levels, maybe different type of analytics at 4 levels.
So that is correct. When people think about data science, they always think of this supreme kind of field of super smart people that do super smart things. But really, data science is in every level of these levels of analytics. And just to give you an example, and we'll get to a somewhat formal definition of what data science is. But for example, descriptive analytics, what happened, right? So you could leverage a data scientist to extract data from a database to understand what happened, right? So all your sales are probably recorded in a database somewhere, right? So data science can then help you extract that data into an Excel sheet or a report or something else. Just like prescriptive analytics can help you understand what the best of course of action is, right? So this is an optimization problem, right? So just highlighting the bottom level and the top level, but the thing really that I wanted to bring home here is that, you know, data science is everywhere across different maturities of analytics and across different positions in the organization as well. So most of the time, people may think, you know, the data science team is very much away from the business, and we'll get to that part later on in the deck. Or people think that data science are people is a separate team, whereas in my view, it should be embedded in the business, right? So data science should be close enough to the business so that it can help making that best course of action decision, right? So again, we'll talk a little bit more about this later, but the take-home message from this particular slide is that data science is everywhere in the organization. You may just not fully know it's there, and you may not fully understand what we do in data science, but that's what the talk is about today.
So Daniel, we have Abdullah saying it can explain at all level, and we have Parinaz who said from the first level and beginning. So it's like first level up.
Thank you for your answer, Chad. It's of course it depends a little bit about what your definition of data science really is, but yeah, I tend to think that it happens on all four levels of analytics. Thank you for your feedback. Now, let's talk about data science, right? This is probably the word that has been most overused the last couple of years. It is a word that everyone claims to be. It is a word that, I mean, there's no diploma behind it. It's not like an MBA or a master's in science, or there's no certification behind it. So everyone can really be a data scientist. But I feel many people still don't really understand what data science is and how it can help inside the organization, right? So I wanted to, before we move to the learnings, which I think is the most interesting part of this presentation, I wanted to talk a little bit about how I feel we should look at a data scientist and where's this person positioned in the organization, right? And to answer the first question, who really is a data scientist, right? Is it something you put on your LinkedIn profile and you get more profile views and messages from recruiters? Or is it something more? And that's what I wanted to cover. So there's a bunch of different definitions here. I'm not going to read all of the definitions here. I'm sure you can always do it after the presentation is over today. But if you look across the different definitions, some of the things that typically stand out is it is an intersection of fields, right? So for example, if we look at the Berkeley School of Information definition, intersection of social science, statistics, information, computer science, right? So data science is a little bit of knowing what the business needs. Data science is a little bit of informatics. Data science is a little bit of statistics. If we look at the definition of mood right next to it on the left, data science is about visualization, right? And we'll cover that later. What's data look like? Data science is about data warehousing, right? So data warehouse is simply where all your data is stored. Data science is, if we look at maybe some other definitions on the top right here, it mentions data mining, right? So what data mining simply is another fancy term. What data mining really is just, trying to find patterns in your data, right? But in order for you to find patterns in your data, you need to have some kind of business knowledge, right? And just to give maybe an example of something that happened to me in a previous role where I was hiring a data scientist. There was a super smart guy and a guy much smarter than I was, and we gave the assignment during the interview to come up with an algorithm which would determine the most valuable customer. So we gave different fields, so different kind of elements about this customer, such as age, country of residence, amount of times transacted. And this model was amazing, especially for an interview assignment. The model looked fantastic, and it was mathematically very profound. But it was one thing missing, and this candidate had missed out on the actual money that the customer had spent with the organization, right? So, and this is not to bash this candidate, but if this candidate would have business experience and would be embedded inside the business, that candidate would know that this is the most important aspect for the company, right? How much money does a customer generate? So in most definitions of data science, I think this part is probably the one that I find is missing most, right? So if you don't understand the business, if you don't understand what the business needs, you can run all the most amazing algorithms or mathematics that you can think of, but then if you cannot apply it in practice, or if it's just missing critical elements, then there is no real value of data science. And then the only thing that what happens is that we as a data science community, we lose the credibility that we can add value and that we will add value to the business. If you look at the bottom left, this definition of O'Reilly's is, it's not just an application with data, it's a data product, right? And I think that's a fairly good summary of my message on this slide, right? So yes, it's important to know a little bit of mathematics. Yes, you need to know some statistics. You need to know some kind of models. So what models are using in what situations. But again, business knowledge is just as important. If I don't understand what the business needs, data science doesn't add true value to the organization. And that's why, for example, I just want to end with the quote on the bottom right here from New York University. Data science involves using automated methods to analyze massive amounts of data and to extract knowledge from them, which again, in my view, is incomplete. You can extract knowledge from them to make a decision, right? Just extracting knowledge, just understanding, for example, what people are saying on Facebook, on Twitter about your organization is interesting, but that doesn't do anything for you, right? You extract that knowledge to then make a decision on how to proceed. So this slide talks a little bit about the different skills. In the original invitation, we talked a little bit about is data science for me? How do I become a data scientist? And yes, there are a lot of different fields, as I mentioned in the previous slide as well, that you need to have some know-how of. Now, I think the most common misconception, and we'll get to a few learnings later on, is that you need to know everything, right? So because it's such a wide topic, right? Because there are so many aspects to data science, in my view, and when I hire and when companies in general hire, I believe they don't expect you to be an expert at every single field, right? So here we have some keywords in red on the slide. So, for example, preparing large computing environments for specialized databases, right? I would not know how to extract data in the most efficient way, right? But, for example, my knowledge of mathematics is a little bit better. When it comes to big data as well, which is just as an overused term as data science itself. What is that really? Big data simply means a large amount of data, but when we say tens and hundreds of times what can possibly fit in Excel. So you would need to have some kind of skills of programming. People will say, I don't like programming. I like my Excel sheets. And we'll get to that point later as well. But again, so as data scientists as a role, so as defined by Gartner, we have your tasks, your mission, and this is where I disagree with Gartner. Says a data scientist may or may not have specialized industry knowledge, right? I firmly believe that you need to have that industry knowledge. When it comes to talent, again, talent is to me is always something that you can improve. right? So you can always learn to become better at databases. You can always learn to become better in statistics. But for example, when I started out my career, I didn't know anything about the industry, and I think that is something that we can all benefit from on this call. If you have worked a couple of years inside a company, again, you know what the company wants, you know the company's objectives, and how you can add value to get there. When it comes to data science, some people want to transition from data science to the business. Some people want to transition from the business to data science. I would argue it's easier to transition from the business to data science than the other way around. Because again, if you don't have that business knowledge, if you don't have that credibility of fully understanding what the organization needs, you'll quickly be put in a corner doing some reports that you don't really want to do. So again, it's in my view, it's easier to transition from the business to data science. I want to highlight, again, I'm not going to go through this entire slide, but I want to highlight one other thing, which again, I'll cover later as well. The top left, one of your tasks is communicating results. And I think we can all agree on the call here that it's very important how you get your message across. Right. So again, and this is why I always believe, data science is not just being the best in mathematics, not just about being the best in statistics, but if you can't get the message across, then again, you're being put in a corner and doing something that you don't want to do. So responsibilities, and just the last thing I want to highlight on this slide, using data mining, visualization techniques. Yes, that is important, and we're going to cover, I think, a very interesting one. But I hope with this slide, I kind of show in the previous slide as well, that you just need a variety of skill sets. And I think this picture here on the left of the screen here kind of shows it the best, I believe. Right. So what does a modern data scientist look like? I don't like this picture, by the way, of this guy. I am a firm believer in suits. I don't like this casual stuff that the guy is wearing. And I feel like in a way that kind of, degrades a data scientist. It's almost as if data scientists should look like this, because this is what people in Facebook wear, for example. I mean, a data scientist is still someone who is part of a company, right? So if everyone wears a suit in a company, then a data scientist should wear a suit in a company as well. But there's this stigma of data scientists dressing the way that they do. So just to summarize, a modern data scientist, what kind of skills can you expect? So math and statistics, right? A little bit of machine learning. Again, another overused term, which honestly is not as difficult as people think it is. Some optimization techniques, right? So for example, when it comes to forecasting, we need to know something about programming and databases, right? How do you even get the data in the first place, right? I mean, you can't do analysis if you don't know how to get the data from the database. Bottom right, communication and visualization. We talked about it in the previous slide, right? So in order for you to really become a good data scientist, and this is something that I always look for when I interview as well, how does this person communicate ideas, right? So often in interviews, I give an open question, and I always tell the candidate there's no right or wrong. I'm just trying to understand how you think and how you articulate your ideas. Visualization, right? We will end with this today. And then the bottom left, I've said it a few times now, I'm really repeating myself, but domain knowledge and soft skills. Right? You can be the smartest person in the world, but then if you don't have the soft skills to work together with people, or if you don't fully understand what the business wants, then all your efforts will go unnoticed.
Then we have a question from Aku. Is the programming language SQL? So probably if you want to share something about what do you mean when you say programming and coding? So that will, I think, help everyone understand it a bit. Unless you want to, you have it to cover it later.
No, perfect. Thank you for that. Thank you for the question. Thank you for the interruption. So programming is very broad in the sense that, so for example, SQL, which is the language that you mentioned, that is typically used to extract data from a database into a report or an Excel sheet or a text file. So it's a good question. So that is definitely something that you would need to at least have basic knowledge of. And then on the other hand, programming, like programming languages. So for example, Python is probably the most common one, because with that programming language, you can actually build your machine learning models. You can build your forecasting tools, right? So you need a little bit of programming in that language to then use that data, which you've extracted with SQL. And then you use Python, for example, whatever language that you like, to then build your machine learning. Just want to make sure if that answers your question.
Daniel, I would just like to, for my own personal interest, would like to ask, at what level, if somebody wants to enter into this, field of data science and data analytics, at what level of programming they can enter into, so does it really need to be an advanced one? Does it, if somebody starts to understand the Python or SQL or any other language, they will be able to start their journey, at least step by step?
It's a very good question, and I'll cover it a little bit later in one of the learnings. But just to answer the question now, this is, I think the cool thing about programming is that even with the most basic knowledge, and even if you're just starting out, my advice is always go to YouTube, search for whatever language that you want to learn, like for example Python, and start watching some YouTube videos, and you will find that it is much easier to pick up than people think it is. People always think programming of like black screen with like green letters and basically like the Matrix, but it really is quite easy to pick up. And what's more, most models, and when I talk about models, I speak about machine learning models, that is often only 4, 5, 6 lines of code, right? So people always think that a machine learning model will take months to produce, but if you actually look at some examples, and you can do that on YouTube after this meeting, you will find that there are many models where it only takes like 4 or 5 lines of code and you have built your first model. So I think the entry level is much lower than what people really think.
Okay, great. Thank you, Daniel. Unless somebody has any other question, we can move on.
So then I want to finish with this slide, because I think this is a great example of someone's profile. When it comes to data science, so there's kind of like 6 areas which are, in my view, important, right? Visualizer, right? So how do you present your data? Communicator, how do you tell people this is the right model and for these reasons? Data wrangler, right? So often data is stored maybe in an Excel sheet, some data is stored in a database. How do you manage that data into a format that can be consumed either by you or by the business? Modeler, right? So how good are you in building machine learning models or AI models? Programmer is simply, again, we talked about SQL in the previous slide, about Python. And then a little bit about technology, right? So of course, you have to stay updated on the different things that happen into the field. But I think, I think maybe you can even use this after the call, just to rate yourself, and then, find those areas that needs the most development and focus on those areas. And again, if you search any of these terms, and if you just search them on YouTube, you will find plenty of resources. So that's one thing I just wanted to add from the previous slide as well. People often think that you need to go to Data Camp. Data Camp is one of the most popular courses for data science. It's a paid-for course, but you don't actually need to invest that money. There's plenty of resources for free on YouTube, complete playlists that teach you everything. And YouTube is actually something that got me through university, and I have a PhD a couple of years later. So again, I don't think we really understand the power of YouTube and the content that's on there. So purpose of this slide was just to show there's these 6 fields really are those required to become a good data scientist, or for example, to transfer, sorry, to, I keep saying transfer, to transition from the business to a data scientist. Now, one of the things when I give presentations or when I teach lectures, I always want to teach one aspect of data science. And again, I'm not gonna teach you, a complete machine learning model. I'm not gonna teach you how to program, but I think it's interesting to consider a principle in optimization. Optimization is the field in mathematics where we're trying to, optimize a certain thing. For example, we're optimizing revenue, or we're optimizing the best possible forecast, right? So it's something that we want to accomplish. I realize I need to quickly go to PowerPoint here. Sorry, give me 1 second. There's some animations here, and the reason why I'm showing this, this example is because this is used everywhere. This is something that's at the heart of many different methods. It's at the heart of many things that we actually do in our daily lives. But you may not realize that this technique exists. Suppose that we have a list of ones, right? So we have 16 million ones in an Excel sheet. I know Excel is limited to 2 million rows, but for now, assume that we have 16 million rows, and every column has the number 1. And it is your task to sum this column, right? So this is not a trick question. Of course, the answer is 16 million, right? If you have 16 million ones, you add them all together, you end up with 16 million. But I think what's interesting now is to understand how a computer would make this calculation, right? Because you can imagine 16 million rows is a very long Excel sheet, and it may take some time to do this calculation. So what this method does, it's called divide and conquer. What this method does is, instead of doing 16 million ones, right, after one another, what it does is, what if we take that 16 million ones, right? So those 16 million rows. What if we split it into 2 groups, right? So we split it in the first 8 million and the last 8 million ones of that group, right? Of course, it will give you the same answer, right? 8 plus 8 equals 16. What if we split that 8 million up again, right? So 8 million, let's split that up into the first 4 million and the second half of the 4 million. And let's do that for both sides, right? So we started with 16 million. We said, okay, we need to sum all those numbers. That will take a long time. So what if we split that to 8 and 8, and then we split that 8 into 4 and 4? You can imagine what's going to happen. We're going to split the 4 million into 2 million series. And we're going to split the 2 million into 1 million, right? So, and this is why it's called divide and conquer, right? So what this algorithm now does is, instead of going to Excel and going through every single row, right? So if we're going through all those 16 million rows, what it does is it splits up that 16 million into 16 1 million pieces, right? It takes the sum of the first 1 million. It takes the sum of the second 1 million. It takes the sum of the third 1 million, and then puts everything together, right? So this is why it's called divide and conquer, right? So you take the first problem, right? So the first problem is, we have, 16 million numbers that we need to sum. And then we divide that problem into smaller problems, right? So we say, okay, what we can do is we're going to take, 1 million. We're going to sum those numbers, which is 1 million. And then we're going to do this piece, which is equal to 1 million. We're going to do the next part, which is equal to 1 million. And why are we doing this? Well, we can solve all those problems in parallel. So we can solve all those smaller problems at the same time. So what ends up happening is that you're 16 times as fast, right? So instead of doing this like 1 plus 1 equals 2 plus 1 equals 3 plus 1 equals 4, all the way up to 16 million. By solving these smaller problems, we can solve them in parallel. And for that particular reason, we can solve them 16 times as fast, right? And this is called divide and conquer. So if you are interested, feel free to Google it after the call. And this is used in many different applications. So for example, when you plan a route on Google Maps, right? So I'm based in Dubai. So let's say I'm going from Dubai to Abu Dhabi. It actually solves that problem into much smaller problems. It solves those smaller problems, and then it ends up with the entire route, right? So just an example of where divide and conquer is used. If you have a very long Excel sheet, right? Maybe not 16 million numbers, but let's say 1 million numbers. What your computer is doing internally is split that up into smaller problems. It solves those smaller problems and then puts the end result together. So I think this is a very powerful example of an algorithm that is used in machine learning, in AI, which is, I mean, I would argue is fairly easy to understand. But again, data science is often spoken about and often thought of this very advanced topic, whereas I think there are many examples of the simplicity of data science.
Daniel, that reminds me of a very, very logical example of goals that we want to achieve in our life, right? If we break them down into smaller portions and smaller steps, it becomes much easier. And so does, I think, the journey towards becoming a data scientist, right? So if we take one step at a time, it would be much easier to accomplish our bigger goal. So most times what happens, people look at the bigger goal and feel that it's difficult to achieve.
Yep.
Right. So breaking it down, I think, into smaller steps makes it easier to make your way towards your bigger goal.
Yeah, absolutely. Absolutely right. So again, so it's something that, you probably even use in your daily life as well, as Abdul Khalik said, right? So to get to a certain goal, right? Or for example, when it comes to, planning a route to your destination. So this is something that we all use and we may not be aware of, but yeah, this is technically part of computer science, right? And used in machine learning. So I just wanted to highlight this example. Now, I wanted to talk a little bit about learnings of data science. So I realize I've already been talking for quite a bit now. And as I said, I don't want to, start with the standard definition of data science and why is data science important, because again, we've all seen this. So I wanted some learnings from practice, right? Some things that we can all benefit from in our daily career. The first question is, should data science support business objectives, or should the business objective support data science, right? So this is more like a chicken or an egg story. Right, so for example, does a business first set their objective? For example, our revenue should be 100 million, and then data science helps through that prescriptive analytics that we talked about, helps to understand how to get there, right? Or should business objectives support data science? And I think Facebook is a great example of this, right? That the data science basically overtook whatever Facebook's original objective was, right? It was just to keep people connected with one another, and now it's just a massive surveillance network, basically, right? So I think that's interesting to think about. The second one, which I think is very important, and I'm sure everyone has read this one, but it is a very important one: garbage in, garbage out. So people will always think, if we invest in the most amazing machine learning model or the most amazing AI model, we will get results. No. If you don't have good data, there will not be any output. And there are no exceptions to this. If you do speak to a company that claims otherwise, they're lying. And it makes sense, right? A computer can only learn so much as you give it to them, right? So if you give a computer garbage, well, it will spit out garbage, right? So learning here, no method will do amazing things without amazing data. Data science is expensive, right? So this is often, this is a statement I often hear. No, I mean, the work that I do in my career, and both for Emirates in the past, Emirates Airline, and now for Microsoft Team, a big conglomerate here in Dubai, all my work is done on a $2,000 laptop. And I understand that's still a lot of money, $2,000. But in a grand scheme of things, right? If you think about it from a company perspective, it really is not, it's not as expensive. You don't, if you're starting out, right? And we spoke a little bit about, you know, how do you start, right? Through YouTube videos. You don't need to invest in a data warehouse, in, you know, all these different tools that people try to sell you. You can start very simply. You can start from a laptop, and you can do a lot of work on your laptop. So as an example, I currently analyze the customer behavior of over 20 million people on my laptop, which is $2,000, right? So point here is that data science doesn't have to be expensive. Data science is difficult. This is also a statement that I think is false. It just requires a wide skill set. And I know that's very easy for me to say, right? But I think the example of the algorithm showed that data science is honestly not that difficult. You just have to have some know-how of mathematics, somehow of retrieving data, some knowledge of statistics. But it doesn't have to be difficult. And I think we always try to overcomplicate things, right? And I mean, I guess that's also why data science commands such high salaries, because there's this myth that what we're doing is extremely complicated, whereas in practice, you'll see that we often use methods which are very simple and are not as AI or ML as you may think. In my view, data science should be closer to the business than its position to IT, right? So I've seen how data science is positioned in most companies, and in my experience, most often they're closer positions to IT than to the business. But then at the same time, companies claim, well, we use data science to make decisions. Well, if that statement is true, why do you not put data science closer to the business, or ideally even embed it in the business, right? If data science is supposed to, you know, support critical decision making, why is it away from the business, right? Why is it part of IT, right? So data science should be close to the business. Then often something I hear, and this is Abdelkhalik, this is the thing I mentioned on the entry barrier of coding, for example. I often hear people complain, I don't like coding, or coding is difficult. I think every one of us uses Excel. And I have an example here. This is, on the left here is the code for Excel. On the right is the same code if I use a programming language. It's a program language. And if you see, the only difference is there are two equal signs on the right. And there's the word else, right? In Excel, it's just if, if. In the programming language, it's if else, right? So this is not an excuse. The excuse, I don't like coding, is not an excuse. Just like with everything, right? There is definitely an entry barrier, right? I mean, the first time you used Excel, you probably ran into the same issue. But people that say, I don't like coding, they're looking for excuses, right? If you use Excel, you use many of the functions that we all use in data science, but then they're equivalent in a programming language. And you actually find that in programming language, it's much faster to execute the same command. But bottom line, I don't like coding is not an excuse. Algorithms are not difficult to understand, right? So often, you know, and I mentioned before, I think all of us in data science, we somehow have to justify our salaries, right? So we try to impress people with AI and machine learning, but often algorithms are not as difficult to understand, right? An algorithm, that definition of an algorithm is simply a series of steps you need to do to accomplish a certain goal, right? So for people to blow this completely out of proportion, it's absurd. We saw an example of one of the most common algorithms that there are, the divide and conquer algorithm, right? Which, you know, if you visualize it, it's actually very easy to understand. So algorithms are not difficult to understand. This is, again, people looking for excuses. Business knowledge or technical knowledge first, right? So I talked a little bit about earlier in the deck, so I will not really repeat this again, but a good data scientist ideally has business knowledge first and then goes into the technical knowledge. And this is why I believe it's easier to transition from business to data science than from data science to the business, right? Because again, why? We need to understand what the objective of a company or the end objective of a company really is. Then I think this is a very, very powerful and very important one. Simple models are better than advanced models, right? So again, perhaps this has something to do with trying to justify salary and trying to justify position. But in practice, what you will find is that methods such as regression, I think most of us have heard of regression, work only slightly, perform slightly worse than deep learning models, for example. But in practice, you would still prefer regression because that is something that you can explain to your stakeholders. You can explain to the business that, okay, we have this and this input, this model predicts, comes up with a certain prediction because, I'm 31 years old. This model comes with this prediction because I'm Dutch, right? So it's easy for me to explain to the business why a model is predicting a certain number. Most advanced models are black box models, which means you throw data in, it spits something out, but it's impossible to understand why it got to a certain number. And therefore, it's much more difficult for me to convince the business that this is the correct model, because again, people don't understand, and therefore there's often some hesitation on wanting to use this model. So in short, simple models are often better than advanced models. There is no right tool, right? So again, if you do go on YouTube, there's definitely people that recommend, okay, you need to buy this laptop, this language, for example, SQL and Python. But just like with everything in life, different things work better for different people, right? So if you don't like Python, for example, don't give up on your interest in data science, right? Find a language that does suit you, like for example Java, or maybe it's C, or maybe it's any other language, really, right? So don't let anyone tell you that there is a right tool to serve a certain problem. Just like with everything in life, different things work better for different people. Then don't reinvent the wheel, right? So earlier on in the deck, I gave an example of how you can basically build your first machine learning model with maybe 5 lines of code. And you may wonder, why is that only 5 lines? I mean, I thought data science is complicated. Well, many of the things that you use in data science, someone else has already done that for you, right? So imagine you're not the first one, for example, in finance to make a forecast, right? Or for example, I'm not the first one in my company to segment customers, right? So many people have already built the algorithms that we need to come up with the final output. So why would I reinvent the wheel, try to, for example, program this algorithm myself, if I can simply use 1 line of code and do the calculations as I would like to get them done, right? So why design something if someone else has already done it for you? So don't reinvent the wheel. So one more example, for example, divide and conquer. Why would you write that algorithm that's already built in Excel, right? So you may not realize it, that's happening behind the scenes, but it's definitely happening, right? So you wouldn't go into Excel and manually separate your rows, for example, the first million rows, then the second, right? So Excel is doing that for you. It's the same thing. Don't reinvent the wheel. Business experience is better than
Daniel, if I may, on your previous, don't reinvent the wheel. What I gathered from what you was trying to explain is that certain scripts to do certain tasks are already built by other people, right? And they are available you can search it up. Is that what, or if that's true, is there any particular source to search certain kind of scripts, or you just Google it and you will get the script that you're looking for?
There's actually a funny, thank you for the question. There's actually a funny meme on what people think a data scientist does and what the data science really does in practice, right? So on the left, you'll see what people think data science is, and then you'll see the matrix with the black square between letters. And then on the right, what people, including myself, actually do in their daily lives, we Google everything, right? So for example, let's say I want to forecast my sales for the next 12 months. Google it, add the keyword, the language, like for example, Python, first result in Google, and the code is there, right? So everything pretty much is already there. And whatever you do at the programming language that you use, for example, Java or Python or whatever, first result on Google, and everything is already there.
So basically what we are saying that we need to learn the skill of finding that script and to use that script, right? So,
Correct.
So we should have some basic understanding of, okay, we searched the script, now what to do with it.
Yeah,
right? So
exactly.
how do we basic understanding of getting that script into whatever, code we are writing, correct?
Correct.
Okay.
Exactly.
Great.
And that's why, of course, you have to still understand how methods work, right? Because otherwise you just copy and paste everything, right? So, but I mean, you don't fully need to understand the mathematics behind a certain model, right? As long as you have the high level concepts. And yeah, it's a matter of, like you say, just learning to search properly, and everything is there. This is an interesting one. And I'll try to speed up a little bit. Don't cherry pick, look at overall performance. So typically when you come up with a model, like for example, a forecasting model, people always cherry pick and say, for example, well, there was one day 4 years ago on 1 p.m. I made a prediction that we would sell 200 and the model said we would sell only 50, for example. And what people tend to forget is that the other 364 days in a year, the model was actually correct, right? So there will always be days where the model doesn't, do its thing, right? There will always be flukes. There will always be black swans. But again, don't cherry pick and look for those particular days. Look at the overall performance, and you will see that models always outperform humans. Don't underestimate data engineering, right? So data engineering is basically the process of getting the data from a database into your programming language or your Excel sheet or whatever. And often what you'll find is that there's missing data may not be correct. Just as an example, maybe an @ sign is missing in an email address, right? Or a phone number, there's no country code, right? So the process of getting data and then cleaning it before you can actually use it, that's called data engineering. And that's often more than half of the effort in terms of data science, right? So just getting the data ready to be used, that often, takes more than half of the actual work. Focus on deliverables. And this is something that hurts to say, because of course, I have a PhD in mathematics, so I always like to come up with the latest and greatest in AI. I'd like to do cool models, but in the end, nobody really cares, right? If you think about it from a business, we care about making money, right? Yes, it's important how we get to the result, but in the end, that's what matters. And that's often why I said that simple models often are even better than more advanced models, because you can explain those models to the end user, right? So nobody cares about your neural network. Nobody cares how you got to the answer. Nobody cares if it takes one line of code that you Googled or if it's 500 lines that you made yourself. It's the end result that counts, right? So focus on your deliverables. I think this is not just data science related, by the way. This is, this goes for everything in the business. Present data nicely. And I'm skipping a few because I realize we're running a little bit behind. Remember to save enough time to present your results. So this is a mistake that I've made a few times where, I have a meeting at 11 and I finish running all my stuff at 10:55. 5 minutes before the meeting, and then I realize I haven't prepared, the results yet. right? So again, when you run your models, you have to present it nicely as well. And I think that is often, the marketing aspect of data science is also as important, right? So these are communication skills, right? So me explaining the model, me explaining the approach, but also, of course, visually on a PowerPoint slide or whatever. That is just as important, just the marketing of your work. The ability to explain your work is very important, right? So just like in school, it's not just about the answer, it's about how you got there, right? So providing documentation is essential, not just to explain your work to your boss, but also if you ever hand your work over in the future, right? So try to explain your works, try to explain all the lines of code that you come up with. Break the status quo, right? So if someone jumps off a cliff, I would not join them. Try to do things differently, right? So just because everyone is using a certain technique doesn't mean that you have to use that same technique yourself, right? So try to do things differently, break the status quo. Give something back, right? So I think this is something that's always close to my heart. So if you do make that transition from the business to the data scientist, empower others to do the same, right? So you'll find that with data science you can do so much, right? You can save time in like very mundane tasks, all the way up to building models. So giving something back can be teaching, but it can also just be explaining others that you don't have to do a whole AR machine learning model. There are other things that you can do with data science that can really help others. So always give something back. And finally, because I do want to give some room for general questions, I wanted to finish with data visualization, right? So this was actually one of the learnings, one of the 20 learnings. And what is the impact of a nice UI and UX? A good example of this, in my view, is we're looking at a graph of the Olympic models, sorry, models, what am I saying, medals, too much data science talk, from 1986, 1890, okay, I cannot talk anymore, until now. And you'll see the different countries right here on the vertical axis. And this is typically how you present the data, right? So just a bar chart, country name. But what if you presented something like this, right? So this is actually a dashboard in Power BI, where your country selection is on the right here. So because we have chosen America, we now have an American flag through the Olympic logo. On the left, you can see the medals, right? So 1131 golds, 901 silver, 792 bronze. The total, participates, the number of sports on top here, the total number of athletes, the distribution between men and women, the different years on the bottom here. But basically what I'm trying to say is that this, to me, really speaks to the end user, right? I mean, if I see this, I'm immediately excited to start to explore the data myself, right? So again, this is just a static picture, so I can't make any selections here. But this is a friend of mine. I've linked his LinkedIn on the top right of the slides here. What he does with Power BI is honestly amazing. So it's a Power BI dashboard. But yeah, so I mean, why present data in this way if you can do the same in this way, right? So this really encourages people to interact with the data and not just open it, look at it for 2 seconds and then look away, which in my view, that's something you would do with this one, right? You look at it for 5 seconds and then, okay, next. This one really invites you, right? And that's why that visualization aspect is so important to get people excited. One last example is also done by the same guy, right? So instead of typically dinosaurs, I think we all, at least in Europe, we get this in school. We learn about dinosaurs, all the different bones and what they're for. But what if you instead of read this in a book, what if you then can select? You can select on certain elements of the dinosaur, so you can explore bones by bone, right? And then you can see different aspects of this particular bone as a whole of the dinosaur. So basically what I'm trying to say is that all these dashboards are highly interactive, right? You really invite, I mean, if you see this picture, I mean, it's a static picture, so again, I can't click anywhere, but to me, this really invites you to learn about the data, right? So you see the buttons, okay, I want to click here. I want to learn more about this. And of course, this is more of an educational example, right? If you go back to the Olympic medals case, that to me, that really invites you to explore the data. And like I said, not just look at it for 5 seconds and then be done with it. So I want to end things here from my side because I realize I've been over time a little bit. I'll just open
Daniel,
the
I
floor.
think quickly I will ask you one question on data visualization, definitely. And I will now invite everybody else too, if they have any questions that you would like to ask Daniel. On data visualization, what kind of tools are currently that are widely available for people to use?
So I think the most two common ones are Power BI, which is done by Microsoft, and Tableau. So when it comes to visualization tools, the same rule as I mentioned before applies. There's no right tool. So you have some people that prefer Power BI, some people prefer Tableau. When it comes to learning curve, they're about the same. Both can pretty much do the same things. So it's just, whatever works best for you. In most companies, Power BI is gaining momentum because it's part of Microsoft, right? So you have Outlook, you have Teams, you have your Word and everything. So, that's typically how Microsoft brands itself, right? As part of the Microsoft ecosystem. But Tableau is just as good. I think Power BI is a little bit cheaper when it comes to rolling it out in an organization. But yeah, they're both are just as good.
Okay, great. Thank you very much, Daniel. So now, if anyone here on the call right now have any question that you need to ask Daniel, then we can definitely take this opportunity. Okay, Daniel, so we have a question from Abdullah saying, is data visualization a career by itself? And what's the difference between business intelligence and business analytics?
Thank you, Abdullah. That's a very good question. I would definitely say it is a career path by itself. So if I can quickly go back to this one, for example, I consider myself pretty advanced data scientist, but I would have no idea how to create something like this. And to me, this is really a piece of art. I mean, again, how you present the data in such a way that really gets people to explore the data. That to me is a very powerful skill. And you also see on LinkedIn, for example, people have really made a career out of just presenting data in a certain way. So the answer to your first question, definitely a career path by itself. When it comes to business intelligence and business analytics, I think business analytics is a wider field of analytics. So business analytics is everything from understanding the mathematics behind certain models to doing the coding, for example. And business intelligence is really, if I can very oversimplify it, just dashboards, right? So for example, in business analytics, you would gain the knowledge to build dashboards, but you would also, gain the knowledge to do machine learning and AI and coding and whatever. Whereas business intelligence is just the dashboards and the reports that you see on the screen. Just checking if that answers your question.
Okay. Daniel, that makes me think about, if data scientist can also be a data visualization or visualizer, if I may say. So because you mentioned that, in order to get to data visualization, it can be one step up, right?
Yeah, so I think visualization is definitely part of a data scientist role, right? Because again, you somehow have to get the message across, right? So for example, if I do customer segmentation, and if I build my model and say, okay, we have defined like 3 groups: high spenders, medium spenders, and low spenders. Then I can simply put that on a PowerPoint slide: 5 high spenders, 2 medium spenders, 12 low spenders. But if I can, visualize that in a certain way, either with images or whatever, like what, for example, we have on the screen here, I think that will, you have a much bigger impact. So I think it's definitely part of the skill set of what a data scientist should have. But at the same time, like I said, there are so many different aspects when it comes to data science that often you're good at a few, but yeah, of course, you're not the best at everything.
Okay, that's great. So unless anybody else has any other question, yeah, so we have another question from Shreyas. He's saying, wanted to understand as to how we can transition to data science role from a different technology altogether. What will be the starting point considering we want to make a career into data science?
So I think, first of all, thank you for the question. I think the best thing, honestly, to do is go to YouTube. And let me just pull up the slide again. Go to YouTube and search for whatever is on the screen here. Right. So on the left here, we have a few different skill sets. So it can be machine learning, statistical modeling, it can be programming, it can be visualization. Search for any of these on YouTube. And stick with a certain channel, stick with a certain playlist. Because again, I think this formal way of data science, where you go to, for example, university or some online school or whatever, is really not necessary, right? So again, how I got into it personally is through university, but when people always approach me, is actually the first thing I always say: don't go to data camp, for example, which is paid for service. Go to YouTube. There's plenty of knowledge and information there, and start with something that you enjoy most, right? So, for example, databases is something that I really don't like to deal with, so that's not something I would start out with. But maybe, for example, you want to understand how machine learning models work, right? So then just search for machine learning explained or machine learning coding explained, right? So then gradually pick up. I don't think there's a set way to really get to the wide variety of skills that you need as a data scientist. So again, start with some topics that are on the slide here, and again, almost like divide and conquer, as Abdul Khalik said earlier. Start with small pieces and then work yourself up to the top. And again, there's no real set path here. Did I answer your question?
Shreyas, did you get your answer? Okay, so we have another question from Abdullah. We'll take this last question and then we will wrap up. Is a career change to business intelligence, data visualization feasible and possible? Or will I have to start with the basic BA/BI visualization degree? And how to transition to business intelligence from a different career?
So can you repeat the first part of the first question? So
yeah, is a career change to business intelligence, data visualization feasible and possible? Or will I have to start with the basic BA/BI visualization degree?
No, so I would not start with a BI degree, actually, or a visualization formal degree. See, when it comes to visualization to me is the output of what we do in data science, right? So visualization is once you have your results and you find a way to get that message across to the business. So if it was up to me, I would always focus on, understanding models, so for example, the machine learning models or the coding, whatever, and then the visualization will come later, right? So you can't get to visualizing something if, you don't have the skill set to actually run the models first, right? So yeah, I would definitely focus on the data science aspect first. And to answer your first question, it honestly is never too late. So just as an example, and I will never forget this. In my second year of university, so I was 20 years old. There was a 62-year-old in the same class. So it has nothing to do with age. It has nothing to do with whatever industry you're in. It's never too late to get into a data science or data visualization career.
Okay, great. Thank you so much, Daniel. Just one last thing. Shiryas is asking, any channel that you recommend. You can recommend any YouTube channel or anything where people go to and find some resourceful information.
What I will do is I will add a couple of links to the deck, and I'll send it to you, Dr. Khalek, if you can then circulate it. I think that's the easiest way. Okay,
yeah, that would be great. So what we'll do, everyone, can we get the recording of this session? Yes, certainly, yes, we can. We will circulate Daniel has, graciously agreed to share the deck, and we will also circulate the video itself of the recording. And the other thing what we will circulate is possibly some YouTube channels or any other courses, right? So for me, I can only obviously Daniel is the best in this to recommend, but I will also say to once you have done your initial research on or learned a little bit basic on YouTube, you can always go to places like Coursera or Udemy or edX. So these are places where you get like courses between $10 to $15 to $20, $25, which can give you a good start to brush up your to start to understand what data science or data analytics is. Obviously, in this 1 hour is just to intrigue your curiosity. If something that you would really like to explore and in your career as a data science. So we will certainly do. We will circulate. So it's just about to wrap up. I wanted to add everything what Daniel has shared. I wanted to just summarize it, in a very simple term that I found on the internet. Obviously, I think this sums up the entire thing. So where you get your data, and once you have data, then sorting it out, arranging it, and this is where Daniel really presented it at the end, the visualization, how you can present to the stakeholders who are looking to look at the data, because they don't care. The stakeholders really don't care how you did it. What they are really focused on, how do you present it, right? So there are various stages of getting your data, sorting it out, and then really presenting it. So thank you so much, everyone, for joining in today. If you have any questions, obviously you can send it to me at abdul.khalek@leadwithak.com, and I will be more than happy to forward them to Daniel and get a response. And we will circulate through this a survey at the end, just a feedback to get it, and obviously everything that we have agreed to with you to share with you. Just make sure that certain times it just goes into your spam or junk email, that you have enabled or saved this web email address, abdul.khalek@leadwithak.com. And Daniel is obviously, you can reach out to him and you can connect with him on LinkedIn. I'm sure if you have any questions, he would be more than willing to help you out. Right, Daniel? This is something I said it on your behalf.
Sure, I'm always happy to help.
Thank you. Thank you so much. So Dr. Daniel Hopman, you can connect with him on LinkedIn. And if you come across any specific question, you can ask him directly, or you can send me an email and I will definitely try to. So thank you very much once again for everyone. We are just 7-8 minutes more than scheduled time. And I appreciate you having it. And the most important part is that you have taken away something from this session. So that's the main objective, just to give you something basic to start thinking about it if data analytics is something for you. and if you like to search it even more. So thank you very much. Thank you, Dr. Daniel Hopman. I really, really am grateful and appreciate your time that you've been here and all the knowledge that you have shared with everybody. Thank you so much.
Thank you.
Thank you. Thank you, everyone.